So a lot of AI apps these days are user-focused. The user types in a prompt and they get a response in real time. Whether this chatbot is helping with legal advice, the company-specific chatbot, or maybe it's a coding chatbot, maybe you're talking to Claude or ChatGPT, either way, it starts with a prompt from the user. You may have sent a prompt, but the prompt doesn't go directly to the model. If the app uses some sort of RAG behind the scenes, it'll start performing RAG. Or if there's a system prompt that needs to be loaded in before your prompt, it'll first load the system prompt. And if you've talked to the chatbot before and memory is saved in the app, then it'll first load up the memory and then load up your prompt after the memory. That's why Claude or ChatGPT or whatever chatbot you're using, it has your conversation history. And when you talk to it, you can jump back into conversations because it's loaded that memory after you've typed in your prompt. So now it builds this context and then adds your prompt in. Now it sends the request to the model. But maybe the model isn't just reasoning. Maybe it's calling some APIs. Maybe it's going to an external database. Maybe it's doing web search. Or maybe it's running some code. And that's tool use, which we'll cover more in the next video. Finally, a response comes back. There will be some guardrails to check if the message is safe to give to the user and make sure it doesn't break any safety codes. So this is the AI app workflow. The user sends in a request, but then it has to build the context before it sends in this request. Then some internal model reasoning happens, and it may call external databases or external API calls to get some data before it returns the result to the user, and we have to make sure that this result is safe. Now I'm going to touch a topic that we've talked about before, but we're going to go more into detail, and this is RAG. So let's say you have a chatbot and you want it to work on some company-specific data. Let's say you have a company, but the LLM doesn't know your company-specific data off the bat, and that's what RAG is for. The model might not know your stuff yet because it was trained on public data, doesn't know your private data. And RAG fixes that without having to retrain the model over and over again, which is pretty expensive. RAG makes this process cheaper. And there are 4 main steps to RAG. And once you understand this, you'll understand how a lot of AI chatbots work that are internal company chatbots. If you want to go really into detail, I've actually covered these 4 steps in my own Medium articles, which you can check in my YouTube bio link. So let's go into the 4 steps. First, you need to prepare your data. You can't just feed it your raw documents, your PDFs, maybe your code. You have to chunk them first. So the chunking splits your data into smaller pieces. So let's say you have a book, it might split into paragraphs. Maybe it's splitting it into chapters. And then after that, you have to convert each chunk into an embedding, which is what we talked about before, whereas the vector of numbers that we talked about in week 1. And each chunk becomes a point in this mathematical space, and it's just a number that represents each word in each chunk. And after we create the chunks and we put them into embeddings, then we have to store them. And the place that we store them is called a vector database. It's not stored in a regular database, it's stored in a vector database. And it's specialized in order to find similar vectors fast. So it's able to connect the chunks together in a way where you can find the similar chunks, and you can also find which chunks are very different from each other. Well, why don't we use a regular database? Regular databases usually function on exact matches. So maybe find all the rows where the person's age is 15, or maybe find all the rows where they have this certain thing. But vector databases are able to search by meaning because they understand embeddings. So find all the chunks that are semantically close to this prompt. That's the job it can actually perform. So it's a different technology completely. It's nothing like an actual database. Here are some quick options that you can use for vector databases. If you're a beginner, you'd probably use Pinecone. This is because it manages almost everything for you, but all you have to do is use it. But if you want some open source usage, you can use Weaviate or Qdrant if you want open source. And then ChromaDB is usually lightweight. It's usually just for prototyping. You wouldn't use it in an actual app or actual production. And there's pgvector. And PostgreSQL is a pretty popular database that people use to store structured data, which is just normal data, not vector databases. So if you're already using PostgreSQL for your internal app structures, if you're adding an AI component, pgvector is easy to integrate because it's part of the same company. So now we've prepared our data and we've stored it somewhere. Now here's for the actual part when the user sends a request to ask a question. This question gets converted into embeddings using the same model that we use to embed our documents. Then the vector database finds all the chunks that are most similar in embeddings. and it says which pieces of our documentation are closest to what the person is asking. And he usually uses cosine similarity, which we talked about in week 1, to find the similarity between embeddings. After this step, what it does is that it generates stuff. So it retrieves the documents and that are relevant, and now we send the model the prompt that the user asks, and we send the relevant documents that the LLM can use now. So now the LLM isn't just guessing, because what if the user asks something specific to the company data and has no idea? So once we do this vector database search, it's able to retrieve that relevant data, and now it's reading your actual documents to generate an answer grounded in real information. This is why we call it augmented generation. Because of the retrieval, it's able to generate things in an augmented way. It improves the generation of it, because if you don't give it these documents to ground on, it'll start to hallucinate, which is when the LLM makes up information when it's not true. So you can go into my Medium articles and you can learn more about the advanced RAG that's shown in this presentation too, such as chunking strategies to make sure that you can retrieve the best chunks of information, or reranking, and there's even hybrid search where you don't just use vector searching. But of course, these are pretty advanced concepts, and of course, if you're curious, you can always look into my Medium articles to find the answers that you're looking for. So that's RAG. You chunk your documents, embed them, store them, and retrieve them. And it sounds pretty clean, and it actually works pretty well a lot of the time. But there's still a problem. Basic vector search isn't always accurate, and this is what I was talking about a few seconds ago when I was saying we just don't have to use only vector search. Like, let's say we search refund policy. We want to know the refund policy of this company. But the top results in the documents start talking about a return policy, it talks about funding allocation, it talks about policy updates. These are not relevant to the refund policy. But of course, it still shows up because it's semantically similar to these phrases. But they're not equally useful. And the most relevant chunk might not be the first ones that are shown to be the most relevant, the ones that are shown to be close to the prompt. And this is why we might use reranking. So the first stage is the by-encoder. This is what we've been talking about so far. It only encodes the query, and then it already has the pre-encoded document embeddings, and then all it has to do is compare it to each one. And then this might pull the maybe top 100 candidates or something. And then stage 2 would be the cross-encoder. This is that careful reader. It takes a query and each of the 100 candidate chunks together side by side, and it actually scores how well they match. And it's a slower process because it paired up individually instead of just looking through all of them and skimming through all of them. Instead of skimming through all of them, it's going through a slower process. But it's a lot more accurate. And that's why it will re-rank these 100 candidates and maybe bring it down to the top 10. So the cross-encoder can catch things that the by-encoder might miss. And a chunk that's semantically similar but not relevant to what the user is asking will get pushed down, while the ones that might not seem semantically similar, but they're actually relevant to what the user is asking, those will start to get higher up. There's also hybrid search, where we can use keyword searching. Instead of doing semantically similar chunks, we can actually just look at the keywords that we're looking for. Let's say there's a very important word that the user might use that's probably really specific, like refund policy. Then instead of looking for things that are semantically similar to the word refund policy, it'll look for the actual phrase refund policy in all the documents. And then these ones can rank higher because it's directly telling what the user wants instead of the semantically similar chunks. So if we take this keyword search and we combine it with the vector search, they kind of cover each other's blind spots and we can get the best of both worlds. And the practical rule is simple. Retrieval gets us candidates, but re-ranking actually picks the real winners. The ones that might place top 5 in the retrieval candidates may not actually be the ones that we're looking for, and when we use cross-encoders and we use hybrid search, it brings the ones that are actually relevant higher up. And of course, this might take a longer time, but it's much more accurate. And if you skip these re-ranking steps, you're leaving accuracy. So that was the foundation of how AI apps work, and then how RAG works, and how RAG is an important part of a lot of AI applications. But we skipped something pretty big in that flow. Remember when I said the LLM takes in all the context, but then it does internal reasoning, and it might take action, like searching the web, calling an API, and doing database queries? That's where agents actually come in, when it takes action. So in the next video, we're going to talk about these AI agents. how they do function calls, how they need structured outputs, how we can orchestrate them, and we'll talk about MCP too. This is the stuff that turns a chatbot into a thing that actually does things. It's what makes applications like Cloud Code and Cloud Cowork possible. So I'll see you in the next video.